Our next speaker is Christine Peterson. She has been at the forefront of a lot of these futurist debates, discussions as the co-founder of the Foresight Institute, which has been trying to make sense of where the future of the world is going and try to come up with a way to be aware of some of the risks but not run away from all of these changes. So, Christine, you have 20 minutes. Thanks.
Thank you, Peter. So the title of my talk, Bringing Humanity and the Biosphere Through the Singularity, I thought was a nice, modest goal for 20 minutes. You notice next to my name I have the word translator. Most of the ideas I'm presenting here are not my own ideas. If there are errors, it's probably my fault as translator, but there'll be citations at the end for those of you who want to speak to the real innovators here. What are the assumptions here? I'm going to assume advanced nanotechnology and augmented intelligence, as described by our previous speakers, both arrive at some point. I'm not specifying when that is. What's the goal? The goal for this talk is to try to identify a pathway for the well-being of unaugmented humanity and of the biosphere. Now, I got some flack from some people saying, hey, what about augmented humanity? Well, I'm looking at the weakest entities here. I want to protect the rights of it's a canary in the coal mine approach, right? These are the folks who need the most help. Given that we only have 20 minutes, rather than deal with the biosphere separately, I'm going to say the biosphere well-being is dependent on humanity caring, I would say. And so it's a human value. It's one of my human values. If it's not one of your human values, I hope it is, but if it isn't, strike that and put in what you value, whether it's art or religion, whatever your personal value is. So we're looking for a pathway for humanity and human values. This, of course, is a general approach. It is not a detailed plan. There's no detailed plan yet. So, augmented intelligence, we have at least 3 pathways. There may be more. You could augment humans. You could augment other species. I spoke, there is actually, did you know there's a congressman, a U.S. congressman who's worried about the singularity? This is Congressman Brad Sherman of Southern California, and I was speaking with him recently. This is one of the pathways he looks at, and I took the opportunity to tell him a point made by Brad Templeton, who's here in the audience, saying, look, make sure, if there's anybody doing this, you do not want to use chimpanzees. Make sure you use bonobos. This is critical. And he said, gee, he takes this very seriously. He said, gee, why is that? And I said, bonobos are much nicer people. And he really listened, because in his talk the next day, he told the audience, if we're going to do this, make sure you use bonobos, not chimps. So we're cool, you know. Congressman Sherman's out there. He's on our side. So the other approach, though, is software, a software approach. And that's the one I'm going to assume in this talk. And the only reason for that is we need some simplicity in doing these thought experiments. It gets much more complicated, I think, with these other 2 approaches. So I'm just going to look at software. What would be the ground conditions for success? I mean, there's nothing wrong, per se, with having lots of brighter or brilliant entities around. That doesn't necessarily cause problems. There's already huge differences in intelligent levels among human beings. What's the problem? Well, the question is whether these weakest entities can hold on to the resources that they need. They need protection from physical coercion. They need protection from economic coercion, such as excessive taxation. You can tax somebody into non-existence. The issue is power and how it's wielded. You know, this is a problem we have today. This isn't a new problem. It just gets a lot worse, I guess. So, we have some experience in dealing with very, very powerful entities. There are extremely wealthy individuals today who are wealthy enough to, say, buy one of the smaller countries. There are very powerful corporations. There are extremely powerful governments. And they can and they do cause tremendous trouble. But we have learned some mechanisms for reducing that, not eliminating it. We have our constitutions, rule of law, contracts, property rights. We have balance of power and checks and balances strategies, mutual defense agreements, game theory. The key thing here, though, is we do need the initial ownership of the original resources, the current resources, by human beings to be respected and enforced. This is property rights. There are different kinds. There's computational and non-computational property rights. It turns out, when you think about it, that securing these non-computational property rights, physical rights, food, these kinds of things, depends on, in the long term, depends on computational property rights, if you think about it. We all know, regardless of whether you buy the singularity scenario or not, We know the world is going to be increasingly computerized. Those computers are, God forbid, going to be running software on them, right? This is increasingly controlling the physical world around us and our resources. If the thought of that doesn't disturb you, then you don't really understand software, I think. So if our computers aren't secure, we're going to be having a very insecure physical world. So let's look at computational first. So what do you need? Well, at the very minimum, and those of you who do computer security know it's a very complicated topic with a lot of layers. I'm going to look mainly at one layer, which is the operating system. You need a secure operating system. You need one that's structured such that a running program has, by default, when it's set up, no authority at all. There are techniques for providing what we call fine-grained access control to resources inside the computer. This is capability security. It provides you a framework with rules for the exercise and transfer of permissions. It's basically a constitutional system inside the software for property and contract. It gives you a minimum framework of, quote, law, unquote, with enabling voluntary arrangements and enforceable contracts. The nice thing about this law is it's not like human law in the physical world. It's more like physical law in the physical world. You can really make these things unbreakable inside the computer. So what results do you get from doing this? You can confine a program to a virtual machine inside this computer. If you were to bring up augmented intelligence software on top of such a system, it couldn't do damage outside the system. It would be confined. And of course, many caveats and complexities not covered here. Those of you who are into computer security who want to follow this up, there are discussion groups on this topic I can refer you to. So let's say you have a layer. You have a layer of secure operating systems. On top of that layer, you build something called smart contracts. These are contracts, simple ones, embodied in software. They are automatically enforced inside the computer. Now, the problem or the challenge here is that the types of rules to be enforced have to be very simple. They have to be much simpler than the current legal code. For example, real estate lease is far too complex to enforce this way. So you'd need to design your contracts and your rights such that the system can understand and enforce them. I believe there is work being done on a language that would be used for these smart contracts. What you do, if you pull this off, what you get is you get an environment, a software environment, where force doesn't work. And that sounds like a good place to me to do, if you're going to have an intelligence explosion, that sounds kind of like a good place to do it. So you have your layer of secure operating system. On top of that, you have your layer of smart contracts. On top of that, you would build automated defense systems, mutual defense systems. And this is where the software world interfaces with the physical world. In order to have such a system, you'd need a consensus on initial asset division. What is a violation of that? What response is merited? And only simple rules can be enforced. In order for this to work, again, the resources brought to bear have to be greater than the violators of the rules. And those who are on the side of the enforcement have to obligate themselves and some resources to make this happen. Now, in this space, you're now envisioning a world with multiple artificial intelligences, of course, and humans, some of whom are on the side of, say, the good guys who are trying to do the defense, and some of whom who perhaps are the not-so-friendly entities. On the not-friendly side, you've got learning components. You're up against a very intelligent and changing entity. You have to have some change in learning on the side of the defense as well. But I've already said you can only enforce very simple things. How do you deal with that problem? Well, you could have a filter that filters this very complex strategizing down to very simple enforcement. The other problem is social engineering. How do you break into a system today? Well, why not just look on the person's computer and see the Post-it note with their password on it, right? Call them up on the phone, say you're the IT guy and you need their password, right? That's social engineering. You can trick people into giving up what they think they want. How do you get around that when you set up your defenses? Well, you can set up something and throw away the key, make it so that people who set it up can't change it. You can require a large supermajority to change it or a long cooling off period to get the stability you want in these systems. The goal is, and it sounds awful, but I don't really see any way around it, you need to have some kind of enforcement system that actually reacts violently to inappropriate violence by any entity. That's defense, right? So how do you build something like that? I've heard the phrase, and this is the first talk title on this topic by Mark Miller, computer security as the future of law. How do you do that? What we have here is we have the E language is one tool that's out there. There are a couple of these capability operating systems that you can use. There's a website about capabilities, and there's another website about contracts. There's another thing I didn't put on here, which is I did a little dummies guide to capabilities myself, and I can give you that if you're interested. Now, this is my last slide. You know, I'm from Foresight Nanotech Institute. You may wonder, well, why am I talking about this? For one thing, Eric did a great job with nanotechnology earlier today, but also these topics interact. When you think about the long term in nanotechnology, we've heard about the idea of nanotechnology weapons, you end up thinking about automated mutual defense systems. It has to be automated. So here are some resources for those of you who are interested in tracking this. At the bottom is the URL for the roadmap project Eric mentioned. If you are interested in technical information on nanotechnology, we have a very technical resource in the spring, a conference in the spring. There's always my blog where I track this kind of thing, and our main website. But the main thing I want to bring your attention to is the middle dot here, the Foresight Vision Weekend. That's where we try to deal with some of these more ambitious topics. We have a lot of attendees here today. It's kind of similar to John Smart's conference in a way, the Accelerating Change Conference. I think due to an urgent need to write a book this year, you may be taking a year off from that meeting. So we are inviting all of you, of course, and all the Accelerating Change folks to join us at the Vision Weekend. It is a members meeting, so you do have to join, but if that's a big issue, give me an email and I'll see what I can do. Thank you very much.